We're continuing our lesson on vertical motion and Newton's second law that we started yesterday. So here's another question. The total mass of a hot air balloon, occupants and a ballast is 1300 kg. Okay, so there's a hot air balloon and it has occupants, that is people, and some ballast. Ballast is some extra weight that is released from the balloon so that it accelerates. So it has some extra weight. Let's say the weight is attached here and it is released to make it accelerate. Okay, so the total mass of a hot air balloon, its occupants and ballast is 1300 kg. So what I'm going to do is I'm going to represent this as a box and we'll have a downward force, which would be the weight, mg. So mass is 1300, g is 10, so it's going to be 13,000 newtons downward force. What is the upward thrust on the balloon when it is traveling vertically upwards with a constant velocity? Okay, so we need the upward force on the balloon. Let's call it force up or upward force. And at what point when the velocity is constant? Constant velocity means acceleration is zero. That means the formula forward force minus backward force is equals to ma now becomes forward force is equals to backward force. Hence, the formula is just going to be the upward force is equals to 13,000 newtons, which is the downward force. So this is the answer for part one. Okay. Assuming no air resistance, okay, before that it says that the occupants now release 50 kg of ballast. So one of these is, let's say 50 kg, they release it. So once that's released, the mass of the system now becomes 1250 kgs. So the weight is going to be 12,500 newtons. So the downward force is going to be 12,500 newtons. The occupants now release 50 kg of ballast. Assuming no air resistance, find the immediate acceleration of the balloon. The upward thrust does not change when the ballast is thrown. So the upward force remains the same as earlier. So upward force minus downward force or force in the direction of motion minus force against the direction of motion is going to be equals to mass times acceleration. So 1250 times A. This would give 0.4 meters per second square. Okay. Next question. Balloon of a total mass 840 kg is rising vertically. So again, I'm going to represent this as a block. It's going upwards. Okay, the weight is going to be mass into the acceleration, or sorry, mass into g. So it's going to be 8,400 newtons. Okay. With a constant speed means acceleration is zero. Okay, so if acceleration is zero, there's going to be an upward force as well. Okay, so upward force is equals to downward force. So forward force, which is the upward force, minus the backward force, which is 8,400, equals to MA. A is 0. M is 840. Not that it makes any difference. So upward force is equals to 8,400 newtons. Okay. As a result of releasing some ballast, the balloon immediately accelerates at 0.5 meters per second. Calculate the mass of the ballast that is released. So let's say a ballast of m kg is thrown away from the balloon. So now the new mass of the system is going to be 840 minus m kgs. So the new mass is 840 minus m, and the new weight is going to be 840 minus m, which is the mass, times g, so times 10. Okay. And upward force does not change. We saw that in the last question's explanation. Okay. So the upward thrust is still going to be 8,400. Okay. Calculate the mass of the ballast release. So same formula, forward force minus backward force is equals to MA. So forward force is the upward force, since forward force is the force in the direction of motion, minus backward force, or the downward force in this case, is equals to mass times acceleration. The new mass is 840 minus m, and acceleration is 0.5. Let's solve this to find the value of m. This will become plus 10m is equals to 420 minus 0.5 m. This gets cancelled. We have 10.5 is equals to 420. This gives us 10.5 m is equals to 420. So m is equals to 40 kgs. This was question number 9. One more question to go. Okay. Here's another question from the book on the same topic. This question talks about terminal speed, and I'm going to copy some text from the book related to terminal speed, and then we're going to understand what that is. Okay, so before we do this question, we need to understand what is terminal speed. Okay, let's read that. Terminal velocity is a constant velocity. If it's constant velocity, that means acceleration is 0, which means we're going to use forward force is equals to backward force. So forward force equals backward force, since acceleration would be 0. Okay, so terminal velocity is a constant velocity that an object reaches during free fall when the downward force of gravity is exactly balanced by the upward drag force, the air resistance. Okay, this is usually observed by skydivers. So at certain point or at a certain body position, what happens that the upward force, let's say this is a skydiver, okay, and at a certain point, what happens that the upward force and the downward force on the diver becomes equal. And the velocity at this stage is called the terminal velocity or the terminal speed. And the acceleration is 0, like discussed before, hence forward force is equals to backward force. Okay, so at terminal velocity, acceleration is 0, so forward is equals to backwards. We've already discussed that. Okay, now let's do the question, since now we know what is terminal speed. So a skydiver of mass mkg steps out of an aircraft. Let's represent it with a block. Okay, its mass is mkg. That means its weight, the downward force, is going to be 10m. The air resistance when his speed is v is given by kv square. So this is the direction of motion since it's going downwards. So this would be the direction of resisting force, which is kv square, where v is the speed. If his terminal speed is 40, terminal speed is again when forward force is equals to backward force. So we have to use 10m is equals to kv square. And v is actually 40 at this stage. So if his terminal speed is 40, find an expression for k in terms of m. Okay, this would be 10m is equals to k times 40 squared. K in terms of m means we have to make m the k the subject. So 10 divided by 40 squared is 1 upon 160. So k is equals to m upon 160. Okay, first part is done. Then it says when the speed reaches 16 meters per second, he adopts a position for which the air resistance is 4 kV square. So now when the speed is equals to 16, then the air resistance increases to 4 kV squared, but the weight is going to stay the same because weight is mg. So m times 10 is still the downward force. Okay. So find his terminal speed. Find his terminal speed. Okay. Now, what is the terminal speed when the forward force is equals to the backward force because the acceleration is 0? So the terminal speed is going to be 4kv squared is equals to 10m. Okay, this will get us the terminal speed. So 4 times, we already know k is m upon 160. V squared is equals to 10 times m. We're going to cancel both the m's and get 4 times 1 upon 160 times v squared equals 10. So we get 160 into 10 divided by 4, 400, and square root of 420. So the terminal speed is coming out to be 20 meters per second. Okay, find his new terminal speed, done. Find also the acceleration with which he is falling just before he adopts the new position. Okay, so just before he adopts the new position is when this is the air resistance, kV square. And just before is very important. Just before he adopts the new position. So just before the new position, the air resistance is going to be kV square, but the value of V that we're going to choose or use is going to be 16 still. Because right before this position, the speed is going to be very close to 16 anyway. So even if you have like 15.9, 15.99 or whatever it is just before the new position, it's still very close to 16. So we're going to still use 16. Okay, so we need the acceleration just before he adopts the new position. Okay, so that would be forward force, which is 10m, minus backward force, which is kv squared, equals to m times a. Okay, so 10m minus m upon 160, that is the expression for k, times v squared is going to be 16 squared is equals to m times a. So we can cancel m on both sides, or you can take m common in the left hand side, cancel it with the m on the right hand side. I'm just going to directly cancel all of these. So I'm getting 10 minus 1 upon 160 times 16 squared is equals to 8, which gives us 8.4. So the acceleration just before he adopts the new position is going to be 8.4 meters per second square. Part B is find also the acceleration with which he is falling just after he adopts the new position. So that is this case. V is going to be 16 and the backward force is going to be 4 kV squared. Okay, so again we use Newton's law. Forward force, which is the downward force in this case, minus backward force, which is the upward force in this case, is equals to M times A. So 10M minus 4 times M upon 160 times 16 squared is equals to MA. Cancels, cancels, cancels. So we have 10 minus 4 times 1 upon 160 times 16 square, getting 3.6 meters per second. That would be all for today. I'm going to be leaving you with some homework from the worksheet. Okay, thank you. Lafis.